Let's continue our discussions on firewall. Again, a firewall is a network security device that monitors incoming and outgoing network traffic and permits or blocks data packets based on a set of security rules. So the purpose of this is to establish a barrier between your internal network and incoming traffic from external sources such as the internet. It's in order to block those malicious traffic like viruses and hackers. You see, when devices communicate, they communicate by sending messages, and those messages are broken down into small manageable pieces, which we call packets. You see, these are the packets that are outgoing, and the other one are incoming packets. A packet is a unit of data that is routed between an origin and the destination on the internet or any other packet switch network. So normally the packets are small, like about 1.5 kilobit lang, and sometimes TCP/IP packets have 64. An example is an email and web pages. As an example, emails and web pages will make use of network packets to send information back and forth to the user and to the recipient. So basically, the goal of the network packet is to send information reliably. So data does not have to be sent in a large single file. So how do we know which packet is allowed to enter the network? Likewise, which packet are allowed to go out? Take a look at this, the structure of a packet. You see, a packet is comprised of header, payload, and a trailer. And from that information, what kind of information you could use to be able to filter the packet? First, you get the internet protocol. So each packet that comes in or goes out has some kind of a protocol. So example is TCP and UDP. Next, we also have the IP address. The IP address of the source or the IP address of the destination. You can make use of those information to be able to block or filter a packet based on the source destination or the source IP address or the destination IP address. And a lot more that can be filtered now depending on the device or type of router or firewall that you are going to use. So based on the information available, we can now filter those packets by internet protocol. So you could see, okay, let's block all protocols with TCP. So you can do that. Or you could block all packets that are coming from a certain source. And that is also possible. Take note that an IP address is associated with a port. Like this one, you have the port number 80 in that case. So if you're going to block that one, all packets that uses that port will not be able to either enter or exit your network. How do we block those packets again? We have to create what we call security rules. Example. Here is an example of a security rule. So we have 9 rules listed in there. So you have the protocol, source, destination port, and action. Let's take a look at the number 1. You see, number 1 has a protocol of TCP coming from 10.1.1 and 20.1.1 is the destination using port number 80. So all those packets will be accepted based on the action that you specify here. So meaning, you come up with a list of rules and then make a recommendatory action. Either you accept, deny, or forward. Right? When an application uses the internet, it uses a specific port. packets enter a specific port on your network. So that's why from the beginning, you should have to close all ports. And by that way, none of those packets would be able to enter or exit your network. But of course, it becomes unusable. So let's take a look at the common application ports. You have TCP protocols and UDP protocols, and you have the applications right here. A common example is your HTTP right here, which uses port number 80. If in the security rule, you would say block port number 80, then there is no internet browsing. Of course, you won't do that. So it's a matter of creating a security rule that will determine which packets you will allow to enter or you will allow to exit your network. Next. When we talk about firewall rules, it uses the first match principle. So meaning, if you have a series of rules, if it matches the first rule, then it stops. In short, it tries to find the rule that matches it. And then when it finds a match, then it stops looking for another match. Right? Next is, we also have what we call chains. So we have ordered chains in sequence. So there are predefined chains, or there are also chains that can be created by the user. There are three default chains. One is input, which goes to the router. So it's an input there that goes to the router. You have output that's coming from the router that goes out into the internet, and forward. So very briefly, if there is an incoming port, what will you do with it? I'm sorry. If there is an incoming packet, what will you do with it? If there is an output packet, what action will you do with it? No? Sometimes, you don't want to take action, you just simply forward the packet and bypass that particular router. Okay? So take note of those chains that we will be using when we do our own implementation using the MikroTik router.